Okay, here's a quick, very unprofessional video that I'm shooting with my cell phone about the parts that I've purchased so far for my solar power project. Please bear in mind that I'm by far not an expert on solar power, so some of the things I say may not be 100% accurate, and I will correct myself later as I learn more and get the system up and running and see how it works in the real world. This first component is the actual solar panel. This panel is an 80-watt monocrystalline panel. This panel puts out 18 volts DC at 5 amps. Got a connector on the back, positive and negative. You can connect these in series or parallel if you need to double your voltage or your amperage, depending. I'll talk about that more later. This next component is what's called a charge controller. Very simple device, goes between the panel and the battery. If the battery reaches 14 volts DC, it turns off the power. When batteries are overcharged, they get damaged. The battery starts, the acid inside the battery starts bubbling and it releases gas. Don't want that to happen. This next component is a power inverter. You've probably seen smaller versions of these in stores like Target and Walmart that you can plug into your cigarette lighter and power your Nintendo or hair dryer or whatever in your car. This is a larger version. You can see here to scale. This one takes power from the batteries in one side. Other side, we have two outlets, 110 volts. This particular inverter is interesting because it can actually be used in a UPS function. You can supply utility power to one outlet and your load on another outlet. If the utility power goes away, the other outlet continues to supply power. So it works just like a UPS that you would put on your computer. Not how I intend to use it, but interesting nonetheless. This is a pure sine wave power inverter. So that there's two more differences between this and a cheap inverter. The cheap inverters, if you looked at the output, the AC output on an oscilloscope, instead of a pure sine wave, you would see a wave that was jagged. It's composed of square waves. Some sensitive electronics and large motors don't work like that because they basically see it like a dirty signal. So it interferes with the electronics. Since I plan to use this on potentially computers and my garage door opener, which is a large motor, we don't want that. This one, the pure sine wave inverters cost more, but they put out a pure sine wave that looks just like the power that you get from your utility or if you plug in a wall. The pure sine wave inverters are also usually smart in their power usage. By smart, I mean when there's no load on the 110 volt side, it goes to sleep. So it doesn't draw any power. It actually draws a little bit, but it's negligible. So this means that when my garage door is not being actuated, I'm not draining my batteries, which is exactly what I want. And when I do activate the garage door opener, it wakes up, puts out the power that it needs. Exactly what we're trying to accomplish here. The next component here is these batteries. These particular batteries are Sears Die-Hard Marine Deep Cycle batteries. Now the difference between a deep cycle battery and a regular battery, basically deep cycle batteries are, they basically have thicker plates in them, or plates that are composed in a different material and manner, such that they're not damaged by being discharged. A regular car battery, the battery in your car typically doesn't drop below 20% of its capacity. Every day you start it, it recharges it, it stays topped off. If you drain a regular car battery all the way down to dead or close to dead, it will recharge, but it won't do that many times. It just won't work anymore. The plates inside get damaged, and then it can't hold a charge. The deep cycle batteries can be discharged down to 80% of their capacity and recharged with no ill effects. You can even completely discharge them and recharge them many times. By many, I don't mean hundreds, but way more than your typical car battery. Car batteries are also, they're usually rated in CCA, which is cold cranking amps. A cold cranking amp is how many amps of power a battery can put out for 30 seconds at 0 degrees Fahrenheit. Why do people care about that? Well, if you've ever tried to start a car when it's cold, you know, because batteries are also affected by temperature. The colder they are, the less juice they have, the less power they can put out. So for a car battery, being able to put out power for at least 30 seconds when it's cold is important. So that's what they're rated at. But deep cycle batteries, it's all about how much power can you put out for a long time. So deep cycle batteries are typically rated, instead of in CCA, they're rated in amp hours. If I connect these two batteries in parallel, by parallel I mean the negative to the negative and the positive to the positive, I will get over 230 amp hours. I will show later the formula for that, but long story short is approximately I will be able to draw 10 amps of power from this battery bank for 20 hours before the batteries are discharged. 20 hours is a long time. That's more than enough to run everything I could run off of this inverter overnight. Fans, maybe a portable AC unit, a microwave, and that's an emergency situation. At the beginning, for the most part, I'm going to use this just to run my garage door opener, which is not, this is going to very easily be able to handle that. So now that being said, I may discover in the real world that perhaps these two batteries do not put out enough to run for, maybe I'm drawing more than 10 amps is what I'm saying. The math gets kind of weird. It's a linear scale. So, if I say I'm getting 20 hours of power at 10 amps, that doesn't mean I'm going to get 5 hours of power at 20 amps. There's a formula that you have to go through. So I'm actually going to perform a real world test and see how many hours I get out of these batteries. I may find I have to add a third battery. I may find that once I add the third battery, this single panel doesn't put out enough amperage to recharge the batteries during the hours of sunlight that we have. So I may end up having to get another panel, put it in parallel. Now I'm getting 10 amps of DC power out of those two panels to recharge these batteries. So that's why this is a project and it's a prototype. I don't have a predefined recipe for this. I'm just kind of figuring out as I go, which is what makes it fun. So that's all for now. I'll post another video when I get the cabling in, and we're just going to be lots of cables connecting these two batteries together. There's a special cable that plugs into the solar panel that's going to go from there to a bus bar to connect the inverter. It's going to be fun. All right. See you guys.